ages ago when I made my first Tesla coil, I put in a RF ground for it to separate it from the house supply. Didn't strictly need it, the instructions that came with it didn't specify it, but a friend of mine said it's a good idea to do, especially if you're going to start getting into high voltage stuff. So I did that and it worked really great, and it's been sitting out there for probably 10 years now. But a couple of years ago I got double glazing put into my house, and the old connection actually ran through the piece of wood next to the window. I drilled a hole, so I don't have that anymore. But since I blew up my neon sign transformer, very sad down there on the floor, the same friend suggested that I make a Terry filter, which is a high voltage, high frequency filter that you can put on, and it should catch any back EMF that comes off the induction from my 1,000,000 volt, the lightning machine. So I want to do that, so I'm going to have to drill a hole in my house, but I figured I should actually test it to make sure it's going to be up to the task, because this is a little bit of a different thing from your regular, from your RF, from a Tesla coil. This will be taking large spikes. So I've had it recommended that what you can do is you take a normal plug, and these are old style incandescent light bulbs, which I happen to have lying around, which is good because they're useful for this, and you wire it up so the live is still connected. And then I've disconnected the neutral here, and instead I have this with a clamp on the end. I can clamp that onto my ground, and if it's good, then the light bulb should light up. So I'm going to try that. Yeah, so here it is. It's about 2 meters of copper pipe driven into the ground there, and some weatherproofing. I had the plastic box on top of it, which is just disintegrated. But dug the wire out, connector up. Oh my god, it works! I think they're a little bit dimmer than they would be on my normal mains earth, but that's success. Now to figure out where I want to drill a hole in my house. So I've got another test I can do. I've spoken to my mate and he said that we can find out what the actual impedance of the earth is. Basically, because this neutral wire is still connected to my house wiring's neutral, so that is a known good 0. If I measure the voltage between my earth output and that, I'll get an idea of what the voltage drop across here is, and then if I put it into current mode and put it in series with the earth, get the current there, I'll have a voltage and a current, and that will give me my resistance. Okay, so we're on, and 90 volts, 94 volts, that's quite a lot. Yeah, I'm not surprised actually, to be honest, because it's not a proper earth, it's just my homemade one, but that's that, and then we'll see how much current's going through. Alright, so we're in current configuration mode. This meter is now in series with the ground earth, or my RF earth, sorry, and we're getting about 389 milliamps. So let's do some maths.